All right, good morning. We're here at the University of Maine compost system. They take food scraps from the cafeteria, approximately a ton a day, and they mix it with horse manure, which is basically a bedded horse manure. And one of the benefits of this material, as I said in previous classes, is that it has a great amount of energy when it comes here. And so this pile could arrive at 140 degrees. The reason why horse manure works so well is because it's at the perfect seed-end ratio. It's around 35 to 40 to 1, so it'll actually compost on its own. The material to use in your compost process is called sawdust shavings. The reason why sawdust shavings works so well is because it contains fine and coarse particles of material that are good and fluffy, and it helps keep your compost well aerated, plus it also provides the carbon that the microbes need for energy and food. So here's where it all begins. They start out by placing a bed of carbon. In this case, this is mostly horse bedding, but the way that this works is that when the food is dropped upon it, all the liquid that comes out of the food is immediately absorbed in the amendment, and that's what begins the process of composting. And it also provides a nutrient sink so that any liquid is not lost from the compost pile. Once the bed has been made and the food has been dropped on top, it's really important to put a cover of carbonaceous material on top of that. Usually we look at more horse bedding, and a layer of 36 inches or so is good to help keep it all together and also help prevent any odors from releasing from the pile. So this pile right here shows the food has been added and the cover has been placed on top. It lets it sit for approximately anywhere from a week to 2 weeks to precondition. Then it's been turned one time. And as you can see, this is just the first turn. They're already at over 112 degrees. So the thermophilic composting process is starting. Now the reason why this is so critical to use in the compost system is really quite simple. If you put straight food in, it has such a thick bulk density. It's somewhere around 2,000 pounds per cubic yard, so it's pretty heavy and dense. In that compost system, it can actually jam it up and cause it not to work. So by pre-composting, you actually get the process started, you initiate it, and simultaneously, you decrease the bulk density so it can go through that compost system without causing any problems to the machinery.
Mark, how do you protect your thermometer from getting bent?
That's a really great question, Vic. So what we do is we use a piece of PVC, and you'll notice that this PVC pipe is about ½ inch or a little bit less, and on the end we have just a coupler, and it's threaded. And believe it or not, when you put your thermometer in, the top of it is made so that it fits in perfectly. Now you're able to protect it, and it's less apt to get bent. This is probably the most critical tool you'll have in your compost process. This thermometer tells you everything that you need to know about your compost pile that you can't see with your other senses. Your sense of smell, your eyesight, this is the extra piece that pulls it all together. Okay, so once again we're here at the University of Maine compost system. This is called the earth flow machine, and the way that it works is that you have an auger that's on a rail system, and the auger moves back and forth, and it starts in the back and works its way forward. When it gets to the front, it moves material backwards as it goes, and over the course of how many days, Dr. Fish?
Usually it's between 19 and 21.
19, 21 days, a more completed compost material comes out the other end to go into curing. And now I have Scott Foster, who runs the facility for the university. He's going to tell you a little bit about the whole system, how it came to be, and other important aspects. Go ahead, Scott.
Well, the whole system actually came to be because the university had a lot of extra food, and they were paying for a guy to take it off campus, and then he was in the meantime process it and selling it as compost. So with a bunch of different people, groups, they all got together and decided this would be the best way to go. So we started it. All the stuff that we do here is pre-consumer. We don't do post. We tried to do post, but post, we got a lot of plastics, stuff we don't want in there. So we went to pre with the kitchens, and this has been probably, I think, 11, 12 years now.
Okay.
And we were able to help out and narrow down the amount of food that's coming out of the kitchens. So when we first started, we was doing, you know, probably 5 to 6, 7 ton a week. Now we're down to about 3 ton a week.
Okay.
So we've been able to reduce it, and all of the stuff that we produce here on campus, it stays on campus. It's not sold, it's not given away. It's used to improve the loam source around campus. Flower beds, we donate to the community around Old Town Orono. U Park also has a garden up there that we give compost to also.
Okay. How do you keep it from smelling?
Well, the smelling part, the best we can do with it is over here is, what you'll see is there's two pipes that come out in here, and they have fans in them. So what they're doing is they're actually sucking some of the smell and the moisture out of it.
Okay.
And these go down through here and filter through pipes.
Okay.
The pipes all have holes in them, and then we put it with like a 3-foot bed of shavings, and as that comes out, the shavings absorb the smell.
Wow.
And it keeps us fairly good as far as the smell goes around here. We haven't had many, well, I don't think we've had any complaints.
Awesome. So this is what we call a biofilter, and what the biofilter is specifically designed to do is to trap odor and allow the microbes living within the biofilter to help break it down. So any phase of your compost process, it's really important that you take temperatures. As I stated in a previous webinar, we need to take temperatures every single day in the same location, and we need to plot it so that we can track how our pile's performing, sort of like a baby picture of your pile. So what I want to do now is show you the proper way to insert a thermometer. The first thing to remember is that the way you angle the thermometer is going to determine the success that you have. If you go straight down at the edge, you're going to end up getting the temperature of the ground. So what I like to do is I like to insert it about waist high at a 45-degree angle, and as I said, the first temperature that I take is the 1 foot. That's the hot aerobic outside zone. That's really important because that tells us how the pile is transferring the air at the outside. We let that sit for 2 minutes to equilibrate. I'm not going to do that here, of course. And then you send it into the center. And the center is the core, and that's the driver of the whole system. As we talked before, compost piles and windrows breathe from their sides up through the center, out the top, called the chimney. So what we have here is a material that is pretty well cured. Both the 1 foot and the 3 foot are reading 82 degrees. So this material I would consider suitable for use in home and garden, as well as possible greenhouse applications. However, before you use your compost, you always should take an analysis. We have many laboratories across the country. In the state of Maine, we're blessed to have the University of Maine Soil Testing Laboratory that helps give us a response fairly quickly, usually within a couple of weeks of being submitted. And what we're looking for specifically to make sure it's suitable to use on crops, plants, and things like that is we want to make sure that the salinity is less than 4 millimoles per centimeter, that the temperature itself is below ambient or close to ambient, so we know it's not going to be active. And we also want to make sure that the C-to-N ratio is somewhere around 19:1. That's when we know there's not too much carbon left in the finished compost. A lot of people in Maine that do compost, sometimes they don't let it finish, and as a result, if you don't let it finish, you can have a high carbon content, and the carbon, when placed in the soil, will rob the nitrogen away from your plants. So we often tell folks to take their finished material and let it cure for another 2 to 3 months, turning it once every couple weeks, and then look to sell it, especially if they're going for a high-end use like a greenhouse. If it's going on a crop, it can come right out of this system and go right in the field, because crops like corn and hay are extremely salt tolerant, and they can handle any of the activity that the compost has as well. All right, so as I said previously in the feedstock class, knowing your feedstocks is super important. Reading a lab report, many of the carbon sources that you commonly work with all read the same. They have the same C-to-N ratio, they have the same percent moisture, they have the same salinity. It's really very difficult to tell the difference. The only way to do that for sure is to get on site and get hands and eyes on your feedstocks and work with them. For example, here I have a bunch of common feedstocks that are used in composting. I have wood chips, I have sawdust shavings, I have hay, straw is also very common in parts of the country, and then I have bedded horse manure. Now when you look at the shavings or the wood chips here, you'll notice that they range in size from coarse to finer. This material right here does not provide a lot of available carbon to the pile. What it does is it provides bulk and it provides airflow, porosity. So this material is ideal for helping build pile structure. The next material I have here is sawdust shavings. Now sawdust shavings is an ideal compost mixture because it has plenty of coarse and fine components to it, and it also has a great texture and the ability to help build pile structure. However, when you ask for pile shavings, you may end up getting something different depending upon the mill that it comes from. For example, this material right here came from a mill that cuts it really fine. That still is pretty excellent for composting, but it's not going to provide as much bulk to the pile. So once again, being able to have eyes on and check this material out helps you figure out the best way to use it in your compost pile. You're also going to get times where you're going to have a farmer say, all I have is hay, can I compost it? And the answer is that this material right here will compost, but the problem with it is that the actual individual pieces of the hay have a waxy type outer coating that sheds water when it's initially used. So this material, it's very hard to get it to absorb a lot of liquid to compost super well. However, if you put this through a hay buster or a chopper and break it into smaller pieces, now the ends are open and available for the microbes to get in and go to work. So sometimes your material that you're composting may need some further size reduction because the smaller the particle, the greater the surface area, the more room for microbes to feed. The final thing to note is that a lot of communities have this available. It's called bedded horse manure. What I like about this is that they usually bed their animals with shavings and with hay, and you get this nice composition, but the best part of all is that when the animals urinate on it and they defecate on it, it starts to come alive with microbial populations. This is the go-to material for composting food, composting mortalities, composting a whole lot of different items. So I tend to favor this if people have it. Usually any drier bedded material that still has quite a bit of carbon in it is a great source, especially if it has an activity to it. A lot of communities have asked, can we use cardboard, can we use shredded paper? In the state of Maine, we're right now telling folks not to add this to your compost pile, partly because a lot of this material is coated with things that you may not want in your final compost process. However, if it's the only feedstock that you do have, and your state allows it, this material is really a good source of carbon and a good source for the compost pile. However, as you can see, this piece is way too large to get the work done, so you'd want to chop it up and shred it so that you have more available surface area. But that's cardboard. There's another material called wax-coated cardboard that's used especially in seafood containers for lobster, fish, and things like that. The wax, once again, sheds water. However, if you grind it, then you can actually get some surface area that's available for microbes to feed on. So, once again, paper, shredded paper, cardboard, used with caution.